Okay, we're going to continue with Unit 4, the final unit of Semester 1, the last section in Chapter 7, Lesson 6. Here are our goals for today. After completing the lesson, I will be able to solve exponential equations. The target for today, have it down at the beginning of your notes, please. So, solving exponential equations. The property of equality of exponential equations is if b to the x equals b to the y, then x equals y. Or simply, if b to the x equals b to the y, then x equals y. Same thing. It's arrow, double arrow means then. So, if we look at this equation here, 7 to the x equals 7 to the third, well, there's not much to do there. The bases are equal, so x equals 3. X equals 3, that's the answer. Okay, let's get a little more complicated here. Okay, so let's look at the problem on the left. 3 to the x plus 2 equals 3 to 2x minus 4. Well, the bases are the same, so that means that x plus 2 is equal to x minus 4. If the x is on one side, the numbers on the other. Subtract x from both sides. Let's start by moving the constant terms. Oops, that's 2x. 2x minus an x is just 1x. Minus 4. When we add 4 to both sides, we get x equals 6. How should we check this? Well, if you plug it back in, you should get equal answers. The same answer is 6 plus 2, that's 8. 3 to 8. 6 times 2 is 12. 12 minus 4 is 8. We get 38 on both sides. We're good to go. On this side, 9 to the 2x equals 27 to x minus 1. You're saying, well, I can't do anything. They're not the same bases. Well, we've learned that we can rewrite these bases. So I can't rewrite 27 as a base of 9, but they both have a factor of 3. And in fact, we can rewrite 9 as 3 squared to the 2x. And we can write 27 as 3 cubed to the x minus 1. So now we use our property rules and we say, okay, well, 2x times 2, that's 3 to the 4x. And we distribute 3 to x minus 1. Don't write 3x minus 1. That'll be 3 to the 3x minus 3. Now we have the same bases, just like we had in the last problem. 4x equals 3x minus 3. Subtract 3x from both sides. And x equals negative 3. Once again, plug it back in, we get 2. X equals negative 3. Yes, that's right. Negative 2. 3 times 2 is negative 6. 9 to the negative 6 should be the same as 27 to the negative 4. Plug in your calculator so you can get the same thing. But that is using the property of equality for exponents. Similarly, with the exponent rule, we have a logarithmic rule. If the log bases are the same, and log base b of x equals log base b of y, then x has to equal y. So here we have a simple equation. Log base 6 of 14 equals log base 6 of 7x, excuse me. So that means that 14 has to equal 7x. So x is 2. On both sides by 7, right? You don't have that. So x is 2. Remember, you should always check your answer, especially for logarithms. Always check. When we plug it back in, we get 2 times 7, which is 14. Log base 6 of 14 is the same as log base 6 of 14. Okay, we're going to do more checking as we go, but you have to verify your answers because sometimes we get what you call extraneous solutions. Let's look at log base 4 of 5x plus 2 and log base 4 of 3x minus 4. They have the same log bases. So 5x plus 2 equals 3x minus 4. So we subtract 3x from both sides. 2x plus 2 equals negative 4. We subtract 2. We get 2x equals negative 6. Divide by 2. We get x equals negative 3. So it appears negative 3 is the answer, right? Well, like I said, we should check it every time just to make sure. So when we check it, we plug -3 back into both sides. Log base 4 of 5 times -3 plus 2. Does that equal log base 4 of 3 times -3 minus 4? So when I plug all that in, 5 times -3, that's -15, plus 2, that's log base 4 of -13. And we get 3 times -3, which is 9 minus 4. That's log base 4 of -13 as well. So we say, okay, everything's good. But what happens when I plug those in my calculator? When I hit alpha window and I hit log bases, log base 4 of -13 gives me an error. When I try and plug it in, it says no real answers. Because really, remember, if we rewrote this in exponential form, this is saying 4 to some power equals -13. You can't do it. You can't multiply positive 4 by itself and get a negative number. It won't happen. So that's why this can't happen. And that's why this is really what we call an extraneous solution. Extraneous means an extra fake solution. It doesn't really work. Okay. So if you try this one, you're going to get the same thing. You're going to get a negative. When you get an answer, you're going to plug it in. It'll be a negative logarithm, which can't work. You can't take the logarithm with a positive base and a negative number. It's an error. Okay, so I'll let you guys write that one down and try that one on your own. Okay, last one. What if we don't have bases with exponents on both sides, just have it on one? Well, we can solve exponential equations by getting rid of the bases, by taking the log of each side. So for instance, this simple equation, 2 to the x equals 5. What log base are we going to use on both sides? Well, it's a base of 2, so we would do the log base 2 to both sides. So x equals log base 2 of 5. How do we figure that out? Well, if we don't have a graphing calculator like we do, then we use the change of base theorem. Take log base 10 of 5 divided by log base 10 of 2. We can get that in our calculator. So log base 10, oops, I'm going to put that. Log base 10 of 5, excuse me, divided by log base 10 of 2. And we get 2.32. Now remember, we also have alpha window in our calculator, 5, and we can just say log base 2 of 5. Log base 2 of 5. Do that. And we get the same answer. So those are the two ways you're going to evaluate. Use the change of base theorem or use the alpha window button. Okay? Down here, very similar, except it's just going to make it even easier for us. We have the log base 10, a natural log. So you solve this one, subtract 4 from both sides. I get 10 to the 3x equals 5. What's the base? The base is 10. So I take log base 10 of both sides. Cancels out. I get 3x equals the log base 10 of 5, which is a button on every scientific calculator. And I get 0.69 or 0.7. 0.7. Now that's not our answer because we have this 3 in front of x, so now we have to divide both sides by 3. And x equals, I left on my calculator, I can just hit divide by 3, 0.232, or just approximately 0.23. Obviously, you plug it back in. When you plug it in, you're going to get, if you round it off to 0.23, when you plug it in for x, you're not going to get the exact answer of 9, but it should be pretty close. Either 8.99 something or 9.0 something, depending on your rounding. Okay? Over here, it's a base of e. How do we undo base of e? We take the natural log of both sides. So 9bx equals natural log of 15. Divide both sides by 9. Now you can save a step if you want to do it this way. Alternatively, we can do alpha y equals. We can do the natural log of 15. And we can divide that by 9. And we get 0.3 approximately. So, put these answers both in here so you can see both ways to do it. Okay? Obviously, you want to plug them back in to check your work. And in here, homework or test. So, did we hit our targets? I think we did. We are able to solve exponential equations. So we'll do some more on the second day of this lesson. We'll have these notes ready for tomorrow. Have a good day.